Welcome to ADV03 Data Mining, Topic 3 Data Mining Tools. Data mining is the set of techniques that utilize specific algorithms, statistical analysis, artificial intelligence, and database systems to analyze data from different dimensions and perspectives. Data mining tools have the objective of discovering patterns or trends or groupings among large sets of data and transforming data into more refined information. It is a framework such as RStudio or Tableau that allows you to perform different types of data mining analysis. We can perform various algorithms such as clustering or classification on your dataset and visualize the results itself. It is a framework that provides us better insights for our data and the phenomenon that data represent. Such a framework is called a data mining tool. So these are the different examples of data mining tools. We're going to talk each of these in the next slide. Orange data mining. It supports the visualization and is a software based on components written in Python computing language and developed at the Bioinformatics Laboratory at the Faculty of Computer and Information Science, Ljubljana University, Slovenia. As it is a software based on components, the components of Orange are called widgets. These widgets range from pre-processing and data visualization to the assessment of algorithms and predictive modeling. We also have the Sas Data Mining. Sas Data Miner allows users to analyze big data and provide accurate insight for timely decision-making purposes. SAS has distributed memory processing architecture that is highly scalable. It is suitable for data mining, optimization, and text mining purposes. DataMelt data mining. It is primarily designed for students, engineers, and scientists. It is also known as DMelt. DMelt is a multi-platform utility written in Java. It can run on any operating system which is compatible with JVM or Java Virtual Machine. It consists of science and mathematics libraries. Rattle. While Rattle has a comprehensive and well-developed user interface, it has an integrated log code tab that produces duplicate code for any GUI operation. The dataset produced by Rattle can be viewed and edited. Rattle gives the other facility to review the code, use it for many purposes, and extend the code without any restriction. Rapidminer. It offers an integrated environment for text mining, deep learning, machine learning, and predictive analysis. The instrument can be used for a wide range of applications, including company applications, commercial applications, research, education, training, application development, and machine learning. Rapidminer provides the server on-site as well as in public or private cloud infrastructure. It has a client-server model as its base. A Rapidminer comes with template-based frameworks that enable fast delivery with few errors, which are commonly expected in the manual coding writing process. So data mining versus machine learning. So data mining relates to extracting information from a large quantity of data. Data mining is a technique of discovering different kinds of patterns that are inherited in the dataset and which are precise, new, and useful data. Data mining is working as a subset of business analytics and similar to experimental studies. Data mining's origins are databases and statistics. Machine learning includes an algorithm that automatically improves through data-based experience. Machine learning is a way to find a new algorithm from experience. Machine learning includes the study of an algorithm that can automatically extract the data. Machine learning utilizes data mining techniques and other learning algorithms to construct models of what is happening behind certain information, so that it can predict future results. Data mining and machine learning are areas that have been influenced by each other. Although they have many common things, yet they have different ends. Data mining is performed on certain data sets by humans to find interesting patterns between the items in the data set. Data mining uses techniques created by machine learning for predicting the results, while machine learning is the capability of the computer to learn from a mined data set. Machine learning algorithms take the information that represents the relationship between items in datasets and creates models in order to predict future results. These models are nothing more than actions that will be taken by the machine to achieve a result. So this table represents the comparison of data mining to machine learning from different factors involving from origin until the scope. Clustering in data mining. Clustering is an unsupervised machine learning-based algorithm that comprises a group of data points into clusters so that the objects belong to the same group. Clustering helps to split data into several subsets. Each of these subsets contains data similar to each other, and these subsets are called clusters. Now that the data from our customer base is divided into clusters, we can make an informed decision about who we think is best suited for this product. Clustering only utilizes input data to determine patterns, anomalies, or similarities in its input data. A good clustering algorithm aims to obtain cluster whose the intra-cluster similarities are high. It implies that the data present inside the cluster is similar to one another. The intercluster similarity is low, and it means each cluster holds data that is not similar to other data. So what is a cluster? So a cluster is a subset of similar objects. A subset of objects such the distance between any of the two objects in the cluster is less than the distance between any object in the cluster and any object that is not located inside it. A connected region of a multi-dimensional space with a comparatively high density of objects. So what about cluster in data mining? So cluster is the method of converting a group of abstract objects into classes of similar objects. Clustering is a method of partitioning a set of data or objects into a set of significant subclasses, which is called clusters. It helps users to understand the structure or natural grouping in a data set and used either as a standalone instrument to get a better insight into data distribution or as a pre-processing step for other algorithms. Applications of clusters analysis in data mining. In many applications, clustering analysis is widely used, such as data analysis, market research, pattern recognition, and image processing. It assists marketers to find different groups in their client base, and based on the purchasing patterns, they can characterize their customer groups. It helps in allocating documents on the internet for data discovery. Clustering is also used in tracking applications such as detection of credit card fraud. As a data mining function, cluster analysis serves as a tool to gain insight into the distribution of data to analyze the characteristics of each other. In terms of biology, it can be used to determine plant and animal taxonomies, categorization of genes with the same functionalities, and gain insight into structure inherent to populations. It also helps in the identification of areas of similar land that are used in an Earth observation database and the identification of house groups in a city according to house type, value, and geographical location. So why is clustering used in data mining? So clustering analysis has been an evolving pattern in data mining due to its variety of applications. The advent of various data clustering tools in the last few years and their comprehensive use in a broad range of applications, including image processing, computational biology, mobile communication, medicine, and economics, must contribute to the popularity of these algorithms. The main issue with the data clustering algorithms is that it can't be standardized. The advanced algorithm may give the best result with one type of data set, but it may fail or perform poorly with other kinds of data set. Although many efforts have been made to standardize the algorithms that can perform well in all situations, no significant achievement have been achieved so far. Many clustering tools have been proposed so far. However, each algorithm has its advantages or disadvantages and can't work on all real situations. So we will talk about each of these examples. So let's talk about scalability. Scalability in clustering implies that as we boost the amount of data objects, the time to perform clustering should approximately scale to the complexity order of the algorithm. Next, we have interpretability. The outcomes of clustering should be interpretable, comprehensible, and usable. Discovery of clusters with attribute shape. The clustering algorithm should be able to find arbitrary shaped clusters. They should not be limited to only distance measurements that tend to discover a spherical cluster of small sizes. Ability to deal with different types of attributes. Algorithms should be capable of being applied to any data such as data based on intervals, for example, numeric, or binary data and categorical data. Ability to deal with noisy data. Databases contain data that is noisy, missing, or incorrect. Few algorithms are sensitive to such data and may result in poor quality clusters. High dimensionality. The clustering tools should not only able to handle high dimensional data space, but also the low dimensional space.